session. I think we have shown now.
So, Joe, welcome. Thank you for joining us today. So, I have the honor of introducing you. I have a special request. You know what it's going to be, don't you?
Yes, I do, but it's probably not going to
happen. So anyway, I'll get to that in a minute. But Joe's got over 20 years experience combined with Oracle and Sun Microsystems. He's spent the last 7 years marketing data science and specializing in the propensity to buy and campaign performance. He's one of these people. I give this phrase "stupid clever," where they're obscenely clever people. And he is an adjunct professor teaching Calc 2 at a local junior college. But here's the thing I wanted, and I wanted to ask him to sing for us because he's previously a semi-professional opera singer, and he spent about 5 years doing shows. So come on, just one line, Joe.
No, it'd be a little awkward.
Anyway, okay. So with that, thank you once again for joining us. We look forward to hearing from you. And the floor is yours, sir.
Great, thanks.
Okay. It was worth a try. If I yodel, will you do it?
I could yodel with you.
Yeah. Yodelay? Actually, Ilvais should be doing that. Okay. All right. Thanks, everyone. Yeah,
there we go. Is the presentation okay? There we go.
Yes.
I believe I'm sharing.
Screen. Yeah.
Perfect. We can
cool.
see.
Just wanted to make sure. Great.
Yeah.
So now the slides aren't moving. Just a short introduction. I just wanted to, what we thought would be helpful for this group is our team had primarily been running machine learning in the Oracle R Enterprise environment with on-prem. And we've done Oracle machine learning for a very long time. When I moved over to Oracle, when we were bought by, when Oracle bought Sun Microsystems, I was very excited to find Oracle Data Miner and started running analysis using Data Miner. And then we moved to Oracle R Enterprise. And in this last year, it was just about a year ago, we migrated from on-prem to Oracle Cloud Infrastructure. So our whole system shifted, and that gave us the ability to request to have Oracle machine learning notebooks. And so once the DBAs got everything deployed, we were able to start running with OML and with the notebooks. And so what we did is we took all of our R code and migrated it not only just to the notebooks, but also to Python. And so what we thought we'd discuss today is what we found in that migration, some of the things that we ran into. And that's where I'm going to go. In general, our background focus, as Roger said, is on mostly propensity to buy modeling. I moved into the marketing org, bounced around a little bit, and mostly what I was working on is helping the marketeers figure out the best list to send to customers. Which customers are the best targets for this product or for this particular campaign. And that kind of grew into what we call our propensity to buy modeling, or our fit modeling. And what we're looking at there is, can we find through our existing customer database, customers that would be great targets for specific products because they don't currently own this product, and we look at their footprint, and their footprint makes them look like they should be buying or having some sort of a subscription to Fusion HCM, for example, or CX marketing, things like that. And so that's what those models are. We have about 40 models in production today. We're continually adding models every month to that for different products. Overall, what we see for our performance is about a 1.5 lift from the win rates that we see with the general population. So we're comparing ourselves to the general population as opposed to just the population that we did not come up with. Our list would be a lot higher if we compared only to the population that we didn't identify as targets. But anyway, we're seeing a great response here, and all of our propensity data is moving not only to our marketers, but a good selection of our sales team as well. So we're seeing, great success there. We've migrated that process to a point now where we are able to score every one of those models on a monthly basis. It takes just a few days to do the whole thing, end to end, from data pull to scoring with an OML. And we're able to refresh very regularly. Our goal is to refresh every model every 6 months. But what we do when we do our scoring is we look at our results and try and decide if the model is performing as expected. And so we will remodel more often as needed. The other half of marketing that the marketeers are looking for is, can you tell me if I have a campaign, is it effective? And the general rule for that is using your standard A/B testing. But what we've done is we've also developed a market attribution model that uses Markov chains in order to evaluate the whole collection of campaigns for a particular product. And that's where my focus is going to be today. So a little bit of a, in the future, I will propose to Carrie and team a full scale presentation on how we've done this Markov chain marketing attribution. But for today, what we're going to focus on is just the first piece of building the data that goes into the matrices that we analyze, and
Yes, please,
some of the issues we ran into there. Roger?
Accepted. Yes, please.
Oh. So that'll be down the line, much more technical. Here's exactly how we're doing this process. But here we wanted to focus on, things that might help you with OML, things that we've learned throughout this whole process and that make us more efficient. And I've already talked about our history with OML, and we're primarily right now focused on OML for Python and SQL. We will have, I didn't have it in the deployment they gave us last year, OML for R. So once we have R, we're going to be thrilled to be working with R again and doing the whole back and forth. That way our data scientists can work with either R or Python, whichever they're most comfortable with. And like I said, today we're going to focus on OML for R, OML for SQL. We're going to pick out some of the main things that we've learned as we went through this process. What we've started to do, and we did this when we were using on-prem as well, is we track, the different ideas, different project packages, and little code snippets that are being used over and over. And we just kind of throw this into a big note file, tracking file, so that we can always go back and say, oh, didn't we do XYZ at one point? And how did that work? And so we're going to identify just a few of those today. So our main use case here is going to be the marketing attribution. Just to give you an overview, a simple overview of what this looks like, we really have a 3-step process. The hardest part of the process, of course, is building out the customer paths. Markov chain marketing attribution requires you to know which campaign touches a customer has had throughout the engagement process until it turns into an opportunity, or which touches a customer had, which campaigns, until it turns into, for example, an opportunity not being created. We need to know either an opportunity was or was not created. We need to know what those touches look like with our campaigns, with our marketeers. And so we have to build out what that looks like. And it really has to be an ordered path that goes campaign to campaign to campaign to campaign that ends with either a conversion or a not conversion. And that is the focus for today, how we did that, okay? Once we have a set of paths, we can use those paths to come up with the probabilities. This creates a matrix that gets put into the Markov chain process. And essentially what you're doing is you're looking at the probability that you touch one campaign and then move to the next campaign. And you only look at the pairs of campaigns. I went to one campaign, what's the probability I go to the next campaign? Or I went to campaign, XYZ, and that what resulted in a conversion later on. So it's just a linear path of what those campaigns are doing and looking at the probability that you move from campaign to campaign. This goes into a matrix of probabilities, and that matrix can then be analyzed using linear algebra to find the conversion rate. And once we have the conversion rate, we can then apply that conversion rate to individual campaigns. And so that's our calculate attribution piece. What we do is we take a campaign out of the matrix, we recalculate what we call the steady state, the conversion rate, and we see how much the conversion rate has changed from where all the campaigns are included to removing this one campaign. And that decrease in the conversion rate becomes our application of the weights for that particular campaign within the path to say, okay, we can give this campaign this % of the pipeline that it converted. Very much high level. There's a lot more detail behind this. But yeah, we're going to focus in just on this build customer path piece. So I'll get you through to the end of how we built the paths. And we're going to start right in. So one of the things that that we always like to do is try and make the notebooks as readable as possible. One of the big benefits that we found from OML moving off of our explanation of all this stuff is that we went from on-prem, where we all had our own instances of ORE on our notebooks, and so everybody had their own code. Well, now with OML, we can share our code within the projects, and it allows us to make the whole code sharing and clean code process a lot easier. One of the things that we've learned we have to do with as part of that is predefine most of the variables up front. So we usually have an initial code block that defines all of our variables, the schemas that you're going to touch for different things, some of the tables in the database that we're going to use, what particular product am I looking at, all of that stuff we tend to define up front. And it makes my life a lot easier because I see that in my first block. I'm not looking through multiple blocks to say, oh, what variable was defined in this particular block. So we are trying to do that right up front. Here we are. Some of the notes on the variables that we have to be careful about is when I'm including variables in SQL strings within the blocks, I have to remember that, you know, if it's a product name, that product name has to show up with single quotes in my SQL string. Otherwise, the SQL string is going to fail. And so I can't just save the product name. I have to save the product name with single quotes and then put double quotes around it so that it gets populated with single quotes. We need triple quotes so that I can deal with multi-line strings. Say I've got, you know, a list of 15 products that's going to go together, and I want that to be my product filter that goes into SQL. I'm going to make sure I use triple quotes so that everything is cleaned. And so we do that up front. And once we have that, we take all of that and we do our syncs and our pulls and our pushes to the database using basically a F string created SQL command. And that way my SQL command is dynamically created from these variables that we define up front. So this OML 101 slide here is about the key things that we use in order to move our data back and forth to the database, right? We're using an OML sync. We have that set up then as an object, and then I use that object down here to do a pull, and I can pull it locally into my notebook. We can push those objects and we can save them. What's really important for us is the data store, because it allows us, when we're doing especially our propensity to buy modeling, to save all of our objects that we used for the modeling to a specific data store, and then any of our other analysts could load from that data store all those objects and start to look at what happened when the model was scored or when the model was created. So when we're talking about loading data, the thing that we really learned is it's extremely helpful to build out this generic query string so that I can use those variables that are populated in the first block of my notebook, and I can use a sync to create my OML object from the database table. For some reason, my code is not showing up. Hold on one second. I don't know where it is.
Specially designed. It's got stage fright.
You think so?
Yeah.
That's very weird.
It's because you didn't sing opera for us.
Oh. Huh. They are just not loading. It worked yesterday.
Well,
Roger, this is Carrie. This is perhaps a good time while Joe's working on his technical stuff to just remind everyone that all of these sessions are being recorded, and our wonderful volunteer Wayne Van Sluis already has up on our YouTube channel the Analytics Plus and Graph demos from yesterday and the day before. So just a reminder to everyone, if you want to check back on YouTube, I can't speak for Wayne, but I'm hopeful he'll be able to get these demos up quickly as well. He's our super volunteer, so just thought I'd share that.
Yeah, that reminds me, Edelweiss, you and I were meant to actually pause between the sessions, so he's got a chance of working out, where they start and where they end, which I don't remember doing at all this morning. So
yeah, so there is also one thing that that we like to mention to our attendees. It's like we have been talking about contact us in a Slack channel and in other social media ways, but we also want people that want to work with us, right? To be part of analytics and data Oracle user community. So if you think, as we think, that the way to grow honestly as professionals is being part of our community and want to spend some time with us and collaborate in any way, just let us know. Just join us in our Slack channel and tell us that you are willing to be part of this community in a more active way. Just let us know. We will love to have you, really.
Yeah, and Edelweiss is our boss with the tech casts, and she's not too bossy, you'll find. So come and join us. Anyway, I see Joe's.
Thank
back.
you guys for the banter in between. I appreciate that.
Okay. We'll leave you to carry on, sir.
So yeah, you were supposed to see this little variable declaration block so that you can see, I'm keeping my schema name without quotes. I have some specific variables that are going to get called within the SQL statement that are going to require those single quotes. And so I'm just putting a double quote around the single quote. That way it'll show up with the single quote. So thank you guys. I don't know why that was working that way, but there you have it. Here at the bottom, you can see I'm just printing these out so that you could see, oh yeah, I've got different ways that I'm printing my schema. I'm getting my variables this way. And this way, these are the pieces that I can throw into my SQL statements, which is what you're going to see next. So just jumping through here. So this is where I realized all of a sudden it didn't show up. So for example, I will define a query string using a fstring function. What's nice about the fstring in Python is that I can put my variables just within those squiggly brackets, and then it'll populate the variable. And so I save this as an F string, and then if I print it, you can see my select statement. I'm just selecting my column names. Here it populated my schema name and my table name. And then it's populating, oh, I've got the product is going to be, my Fusion sample product. The time frame is this list. And that way my SQL I know is going to work correctly because it's printing out all the things correctly. And then you can see the next step here. I define dfloc to be my OML object, and it's going to be pulling the use an OML sync. It's syncing up that this select statement. Basically, it's using my schema name and it's using the query string that is defined right here. So it's just running this query string and syncing the table that results from that. And that's what you're seeing here, is the top few items from that table. Now, one thing that we did run into is I built this whole table for my dynamic attribution, for marketing attribution, and I ran into some date field errors. It turns out that date fields are currently not supported. I've been reassured by the team that they are going to be. But what I've done is I'm just either using a numeric straight date or a string date. And so within my SQL statement, here's the error that I get. Within my SQL statement, I'm doing a to-char on my date fields. And that allows me then to bring them in, and I can, here's my date fields. You can see I'm setting some of these as string. My response date old, I'm setting it as string, okay? And that allows me then to run a to date, I have that here, on the string to date time on the string, and it'll convert it to a pandas date time variable, okay? And so once I have this now as a date time variable within Python, I can then go ahead and do my sorting on that date. As you remember, the whole goal here is to get an ordered step for my customer. And that's why I need these dates to be able to follow a specific order. So I would look for my customer number, my product, my region, and I would be making sure that I've got an order for the touches that I'm seeing for my customer, the campaign touches. Those are in the ... part. I am also typically at this point, because I'm going to be using Python commands, I'm pulling the data into my session using pull. Remember, it's just your object name .pull is how that works. And so it's creating locally my df object. And that's the one that I'm actually working on. All right, there I change my field to the date time, and then I can do my sort, and I'm sorting with grouping. And so I'm grouping by my time frame and my company identifier and by the response date, okay? Now, the really interesting thing that we found is we were defining functions. What we did when we built out our attribution process, we actually built this thing in both R and Python on local environments. And we realized, we really need to get this into OML, and we migrated the code. So what we did with Python is we had created a class and just a little bit of code around that class, and took the whole class, put it into a Python block in OML, and it was able to run without any problems. We got the exact same results. Everything worked great. The only changes we had to make was connecting to the data tables differently because they were in the database. Some of the, after presenting our results to a lot of the marketeers, they of course asked for more information, looking for more data, more detail around some of the things that are happening, stuff like that. The class that we had created was so black box, it didn't allow us to do some of the analytics that we really needed. And so we had to take that class, break it apart into all its composite functions. And as we started doing that process, we realized that OML has multiple ways to define a function and multiple ways to call a function. And it's really quite interesting how this works. So the first thing is, you can define a function using standard Python. You use the def command, you put in your variables, name the function, all of that stuff, standard setup. The other option you have is you can take that defined function, set it equal to a string variable by enclosing it within triple quotes. Doing that allows you to do some other things with that function. So for example, we have our functions, we can have it defined within Python. I could save it to my data store as an object, okay, that particular function. Or I could take my string enclosed function and I can use OML script create and save my function that way. And what that does is it creates that function within the script repository in the database. If you set your parameters to allow other users shared, basically, they'll allow have it shared among users, then other users within any script who have access to that function can pull that function into their local environment. And so this is a really nice way where when we have groups, functions that we're using on a regular basis for different analyses, we could save it to the script repository, and other data scientists can bring that into their notebook without any trouble at all, rather than trying to find one notebook function, copy and paste, and put it into the other notebook. With the script create, we're using a named string with that triple quotes. I'll show you an example of that in a minute. Or, like I said, you could save the object to the data store and then load the object from the data store. You have both options. And with the saving an object to a data store, you could either use the Python name for the function or the named string. The last piece of this is, how do we call those functions? All right, we can actually call it as a local Python function, and that's what you're doing with this defined function. With the name string and with the name function, you have some other options. You have an OML do eval, which does some embedded Python execution. All right, with do eval, you can include the name string. I'm going to show you examples of all these in the next slide. You could use the Python function, or you could use the function that's saved to the script repository. And all of those work with do eval, okay? You can also load the script either using script load or using the data store load, and use the function that you loaded, all right? So it gets kind of crazy because there's all these different ways to do things. And then the matter is, which one makes the most sense? For us, using the script repository makes a lot of sense because it just allows us to share common functions that we're going to use all over the place. So let's go into the example, right? We want to create a function using DEF. This is pretty standard Python. You define the function, here's the function name, and there's my variables. And this is just a simple function to pull in my data and correct the date, just as an example, okay? I can take this same function and define it as a string using the triple quotes. So here's my new function name. It's basically just a variable in the script, dat_pull_loc. I'm using triple quotes around it, and notice it's just triple quotes around my dat_pull function. You'll notice one difference here. Because I know eventually I'm going to use this dat_pull_loc in a do eval, I need to make sure that I have my import of the packages that I'm going to be using within the function. All right. And so I've added the imports for OML and pandas within my function, so that when I do it on eval from the script repository, it's actually going to launch those packages when it launches the function as well. All right. So that's why I'm including those packages. So there's my two definitions of the function. And then if I'm going to call the function, here's my function, I can just run dat_pull, putting my variables in. That's standard Python, works as expected, okay? If I call my function using do eval, there's a little bit of nuances that we have to be careful of. First of all, notice in this case, I'm just pulling that function using do eval, all right? When I put in my variables, I have to make them equal to something. So I have query string, I'm setting it equal to the query string variable in my notebook. Schema name, I'm setting that equal to the schema name in my notebook. If you don't have those equals there, you will get an error. If you just try and call it with a do eval with just the two, thinking that it's just going to populate from your variables, it won't work. You do actually have to do those definitions where you set an equals, okay? But notice this is just calling the exact same function, dat_pull. It's just using two different commands, standard Python or OML using do eval. Now, in addition, we can use do eval on a string defined function. And the way that looks is like this. Here's my query string, just a select statement. I'm going to run do eval, and it's going to use dat_pull_loc. Remember, 2 slides back, I saved that function as a string in dat.pull_load. And so now it's calling it that way. The reality is you could just put that whole string here in the equals, that whole definition of the function. But that would be extremely messy. So it's nice to put the function name there, which is just a string. Here, now it's setting my query string equal to this query string, and I have my schema name, which is preset. Now, the last option is we can use the script repository. And so what I'm doing here is I'm using script create to create the function dat.pull_db in the script repository. It's using dat.pull_loc as the function that it's creating. Dat.pull_loc, remember, is my string version of the function. Overwrite just allows me to overwrite this function. You got to be careful with that because you don't want to overwrite somebody else's. And is global, I'm going to set this one to false. If I set it equal to true, that means anybody accessing the database through OML can use this function. You can even put a description that says what this function does. Okay. The way I run using the repository is I'm going to call my function dat.pull_db, but I'm putting it in double quotes. All right. Without the double quotes, it doesn't know to use that function from the script repository. Same setup here. I do have to define my variables with an equal sign so that it knows what things it's sending to the function. All right. So this was the big learning for us on using functions. We were trying to do one set of functions, and then we're like, let's try and do some do evals, and it was breaking, and we realized there's lots of different ways to do eval. So there you have that. The function I have on the right here is the function that we pulled out of our class that we created that creates our customer path. So that's what I'm going to get into now. So we had the standard function that we created to create the customer paths, and it does all these different commands. This runs perfectly fine in Python. Okay. What this thing does is it first defines the groupings with my group by. Okay. It'll sort within that group by the response date, and then it'll create the paths and order them response 1, response 2, etc., based on the date. Part of the way I set up my matrices is I have a start probability, which basically tells me what's the probability that I start at a particular campaign. And then we have a converted no conversion probability. What's the probability I'm at one campaign and I go to conversion, or the probability I'm in another campaign and I go to no conversion. So we have to append those start, converted, no conversion to my paths. And that's what you're seeing here. This is the appending to the paths. Okay. When I run this command within Python, it takes about 4 minutes, which isn't horrible for the example that I set up, but some of my data has 5,000 campaigns that I'm analyzing for a particular quarter. And so the timing can get a lot longer. And one of the things that we were trying to do is to see if we can tune our code so that we can get this whole process to run a lot faster. For some of our products that have way more, a large number of campaigns, it would take us, 30, 45 minutes to run attribution for a single quarter. And so we're trying to tune that process down to be a lot faster. Now, just a little side note, I've been focused on Python code blocks. And so we're going to do a little side block on the code block options. Here, you have a standard Python code block, you use Python commands within there. Another option would be we could do %SQL, right? And that allows me to run SQL statements, which are single line statements like select star from my table, all right? Finally, there's a %script option, which allows me to run PL SQL. And those are the full blocks where I'm looking at %script, and then I've got my command, create a function, begin, get into what's happening with my, do my begin and end statement. The whole block is basically what's happening within %script. There's also %MD that you can use if you want to put markdown commands within your script, things like that. But for now, since we've been focused on Python, we're using Python and we're going to do some SQL as well. So talking about the script versus the SQL, you know, my script command looks something like this. This is just a copy directly from it. And what I did, that function that you saw, I recreated that function as part of our tuning process as a SQL script. So just a full script that'll actually do the exact same code, only it's doing it within PL SQL. In addition, you know, here's what it looks like for using %SQL. All right, we saw some of this on Steve's presentation. %SQL, select star, here's your table result. Now, those are ways that we can implement our SQL within our OML script, right? And one of the things that I did is I took that PL SQL block, threw it into a script block, ran it, and it builds tables in my database that I can then use OML pull in order to pull into my OML script. Running that block versus running the Python blocks is a difference of, you know, it takes about 15 seconds to run that PL SQL block and build the tables versus doing all of the manipulations that I was doing in Python. Huge difference in the amount of time that we saw. And then what we thought was, well, let's really compare the difference by creating a block that executes the PL SQL within the block and does the exact same commands that we're doing within Python so that we could do a true comparison of timing. And as part of that, what we did is we created that same PL SQL, turned it into a procedure, and saved it as a procedure that I could just call by putting in the grouping variables. So it puts in the grouping variables, calls the procedure, and then builds the two tables that I need as output, and then it pulls those tables into my local notebook. So that's what we're doing. So in order to make that happen, we had to use what's called the OML.Cursor command. And what we found is having OML Cursor is so much more helpful for our processes, because rather than having a Python block and then a SQL block and then a PL SQL block and bouncing back and forth from the different blocks, we can actually use OML Cursor to embed the SQL in our Python block. And that was just really a huge improvement in our processes. It allows some scalability. It allows us to create procedures within the database that we can then call within a Python block. It just really saves us a lot of organization and adapting. Really helps us automate our scripting because we've got our parameters defined up front. And so now when I define those variables up front, if I go to a SQL block, I can't call those variables. But if I use it within a Python block, I can call those variables using an F string and then run OML Cursor with that SQL string that I've created. And so all my variables then can either be pre-input or dynamically generated. And I don't have to worry about the fact that I'm jumping into a SQL block and now I have to redefine variables, right? And like I said, you could save that procedure in the database, or you could build a full SQL string that'll execute. So a lot of hesitation there, but here's the big picture of what this thing looks like, right? So in pure Python, I'm basically running this for loop. And at this point here, I have my create customer path function, the one that I shared earlier. So we create the customer path, we put in our variables, and my output is two tables, sort events and df used map for this grouping that I'm looking at. And then it'll take those two tables and run the rest of my attribution on those tables and give me results. Okay, so I'm only giving you a short snippet here, but in pure Python, that's what that looks like. In using OML Cursor, what that looks like is I have to modify it a little bit, but here's the for, right? For at and attributed to, they're both in the same place. I have my combination of variables, right? My groupings. What I did then is I added the query string build so that I have my F string. And basically it's just a begin end where I execute my procedure, create customer paths. But I'm able to take my variable combination and put combination 1, combination 0, combination 2. I know there's better ways to do that, but for these purposes, I just did it that way, which populate the variables that are being used: response date, what's the product, all of those variables that need to go to my procedure. They're auto-populating from this combination variable. And so that helps me a ton, because that can be auto-populated. I can print the query string so that I can see what it looks like. And then I'm using the OML cursor. And basically what you do is see, I made a variable equal to OML cursor. I do cursor.execute. I execute my query string, and then I close the cursor. The query string is building 2 tables in my database: sort events final and df_used map final. And so those 2 tables get built. I can populate with an OML sync tag to a pull sort events, which is what is happening here. And I can tag with an OML sync dot pull df_used map, which is what's happening with the second variable here. And so I get my result populated into those 2 data frames locally, and it's just running the procedure within the database. Okay. So yeah, the big picture here, or the big learning for us is, yeah, it takes a little bit of extra code to make this thing work, but when I go to evaluation, I find using my do evals or my regular Python function, it's taken about the same amount of time. It's taken about 4 minutes for all of those. With my PL SQL script with OML Cursor using the procedure, it takes 9 seconds to do the exact same command. And so, the big moral for us is, as data scientists, we're so used to working in R and Python and making Python and R do all kinds of data manipulations. Well, OML gives us the tools and the ability to embed SQL, embed scripts, and to actually do it completely within the database. And so we want to use that SQL for our data manipulation. It just makes a huge difference in our timing. If I can get this timing down from 4 minutes to 9 seconds, that's going to take my 45-minute data run down to, just tens of minutes or less. And we haven't done that yet, but that's our next step, and that'll be part of our next presentation. But I'm going to stop here. This was everything that we put together for today.
Superb, Joe. Thank you. I realized I butchered your name when we first started. I think I called you Darschewski.
Oh, I didn't notice.
Yeah. So, and I remembered afterwards you'd coached me even. So forgive me.
No worries.
I don't have any specific questions, but I don't know if Edelweiss, if you had anything to ask.
More than to ask is just to emphasize something that you have said at the end, that you use the right tool for the right job. It's very common that we are kind of used to use some product and work on that and try to do anything with that. And it's funny because I use the same sentence in a machine learning presentation that I have with Autonomous Data Warehouse and Oracle Analytics, and I said the same thing. Use the right tool for the right job. So use the machine learning in the Oracle database, right? That is the way to do it. And you saying the same thing with the SQL or Oracle machine learning for SQL, or Oracle machine learning for for Python, or use SQL and PL SQL for access data. That's very useful.
4 minutes down to 9 seconds is quite an optimization, though. Yeah, I mean,
it was huge. I was in shock.
Huge. It's huge.
Yeah.
Yeah,
Totally.
it just made a huge difference. And really, that's running the exact same code block. The only difference was adding the OML cursor in and pulling the data. I thought pulling the data might make it take longer, but it did not.
Phenomenal. Yeah. Well, thank you once again, sir.
And we have sorry, Roger. We have a couple of questions.
In a couple.
Oh, there we are.
Yes.
Yes, they've started to arrive.
Yeah. So is any of these Python codes available for us to refer? And if it could be in GitHub or any other place, maybe we can share something in our Slack channel. The
Sure.
link for that.
I actually don't have them shared at this point. We were working on that and ran out of time. I'm actually going out of town in about 4 hours, and I just didn't have time to put it together. But after I get back in a couple of weeks, I will try and put that together, and I can get that to you, Edo, if we can post it with the presentation.
Yes. Yeah. Perfect. We can post it with the presentation and also in our Slack channel, Anand. So if you just join our Slack channel, you will have the information in a couple of weeks. Thank you.
Cool.
Perfect. All right. Well,
thanks, guys. It's been a pleasure, and you know, keep an eye out for marketing attribution major presentation. That'll be much bigger to try and explain that whole process.
Well, seriously, we would love to have you back, even if it's one of our TechCast events.
Exactly.
You know, during because we do them every couple of weeks as well. So when you're ready, just send us a note and send us an abstract, and we'll get you into the schedule, sir.
Will do. Cool. Thanks a lot.
All right.